Hello students. Now we are going to discuss about essay type questions, and you can expect one question compulsory in board examination for 5 marks. So earlier it was 4 marks, now it is 5 marks, and please be focused because it is a compulsory problem, and you can score 5 marks easily from this. So for that I listed out a few set of problems which were given frequently in previous board examinations. So we'll be starting with the first problem, that is, prove that 2 plus root 3 divided by 5 is an irrational number given that root 3 is an irrational number. I just want to explain one very important thing for this. Prove that 2 plus root 3 by 5 is an irrational number given that root 3 is irrational. Suppose if this information is not given that root 3 is irrational number, that information is not there, purely you are asked to find out or to prove that 2 plus root 3 by 5 is an irrational number. Then what has to be done, and how many number of ways of doing this? See, there is a straight problem given, like prove that root 3 is only irrational number. The given question is prove that root 3 is irrational number. In order to prove this root 3 is irrational number, then we will have to follow the systematic way that how to prove root 3 irrational number. That is what by indirect method of proof. By indirect method of proof, we will prove this root 3 is irrational number. Of course, we will have a one problem. Okay, so we'll definitely discuss about completely about this kind of problems. So why am I telling you here? Because if you see in your textbook, you can find out this kind of problem. In that problem, this information is missing. So since this information is missing, then they proved it in another way. The way is going to be that what I am going to explain you now. So that is, just see, I will tell you the difference between both the ways. Given that root 3 is irrational number, so I am going to write what is given. So given that root 3 is irrational. Given that root 3 is irrational. Now you are going to prove 2 plus root 3 divided by 5 is irrational. So in order to prove that it is irrational, let us go by indirect method of proof. What is this indirect method of proof? I will try to explain you about that. See, in your textbooks, these kind of words are not being mentioned anywhere about indirect method of proof or direct method of proof. But there are two types of proofs in order to prove any mathematical statement. Hope you understand. There are two types of proofs in order to prove any type of mathematical statements. For example, even you have seen in grade 9, okay, even in grade 8, in some geometrical concepts like prove that in an equilateral triangle ABC, AB is equal to BC is equal to CA, then angle A equal to angle B equal to angle C is equal to 60 degrees. That is one type of problem. In that problem, you are given the triangle is equilateral provided that AB equal to BC equal to CA, and then you are going to prove that each angle is equal to 60 degrees. If you closely observe that statement, the information given as taken as hypothesis, that is what you write it as given, and through some logical sequence of steps you may end up with conclusion, that is what RTP. Hope you understand. We will write what is given and what is RTP, and then through some logical sequence of steps we will approach the final result. That is what you called direct method of proof. Of course, till now you heard, you practiced, you are experienced with only direct method of proof. You may not ever have indirect method of proof. Now in this indirect method of proof, we begin with RTP. That is conclusion, saying that our RTP is wrong. Hope you understand. Saying that our RTP is wrong. What is our RTP here? 2 plus root 3 divided by 5 is an irrational number. That is wrong. That is what is our assumption. So in this indirect method of proof, we assuming that our conclusion is wrong. Did you get my point? In our indirect method of proof, we assume that our RTP is wrong, and through some logical sequence of steps, we arrive at a contradiction. What is meant by contradiction? Getting a wrong result. Why are you getting wrong result? Because in the beginning you have started with the wrong assumption, isn't it? Since your assumption is wrong, so finally your result would be wrong. So this is what is called indirect method of proof. Hope you understand what is the difference between direct and indirect method of proof. In order to prove either root 3 irrational number or this kind of numbers are irrational numbers, so the most easiest and the most useful method is indirect method of proof. So let us start with this indirect method of proof. By indirect method of proof, let us assume that what is that number? That number is 2 plus root 3 divided by 5 is not an irrational number. If a number is not irrational number, then what kind of number it is? Must be a rational number, right? So let us assume that 2 plus root 3 by 5 is a rational number. What is that number? Is a rational number. So we know, according to the definition of a rational number, every rational number can be expressed in the form of P divided by Q or A divided by B, provided the denominator should not be 0 and both numerator and denominator, they are P and Q are integers and must be in the standard simplest form. So in the simplest form means the greatest common divisor or highest common factor of numerator and denominator should be 1, then only they are said to be in standard form. So that I am taking 2 plus root 3 divided by 5 is equal to P divided by Q. Okay, so here Q is not supposed to be 0 and P comma Q are integers, and provided HCF of P comma Q is equal to 1. Okay, so this is one of the most important point here which decides our result. So please do remember that 2 plus root 3 by 5 is equal to P by Q. Now I'll try to simplify this. So what do? I will have to cross multiply. Then 2 plus root 3 into Q, otherwise transpose is 5 that side. So it would be 2 plus root 3 is equal to 5 into P is 5P divided by Q. Right? Then what is root 3? Root 3 is equal to 5P divided by Q minus 2. 2 means 2 divided by 1. It is going to be 5P minus 2Q divided by Q. So we got root 3 is equal to 5P minus 2Q divided by Q. See here, according to the information given here, given that root 3 is irrational number, so this number is purely an irrational number. Irrational number means belong to Q complement. Then what about 5P minus 2Q by Q? Since P and Q are integers, integer multiplied by another integer is again an integer. Integer multiplied by another integer is again an integer, and the difference between two integers is also an integer divided by an integer. So integer divided by integer can be an integer or can be a fraction, means it should be a rational number. So 5P minus 2Q by Q is purely a rational number. What we got here? An irrational number is equal to rational number. An irrational number never be equal to a rational number. Hope you understand my point. But here we got an irrational number is equal to rational number. So this is a contradiction. This is a contradiction. Contradiction means what? Getting wrong result. Since this is a contradiction, why did we get a contradiction? Why we arrived at a contradiction? Because of our wrong assumption. Therefore, our assumption is wrong. Our assumption is wrong. So then what is correct? Therefore, 2 plus root 3 divided by 5 is an irrational number. So this is what the way of proving the given number is irrational number. So hope you understand how to answer this. This kind of problem is compulsory in your board examination. So please concentrate on these kind of problems, and this is only the systematic way to prove this. Hope you understand. Let's move on to the next problem. So the next problem is going to be, show that there is no positive integer n for which root over n plus 1 plus root over n plus root over n plus 1 is rational number. So according to the given problem, there is no integer n, there is no positive integer, exclusively it's a positive integer n, for which root over n minus 1 plus root n plus 1 is a rational number. Means it will never be a rational number for the value of n is a positive integer. That is what we are going to prove. See, this is also just similar to the previous problem. We can answer this problem by indirect method of proof. Okay, I am going to choose indirect method of proof. So by indirect method of proof, let us assume that what is that number? That number is root over n minus 1 plus root over n plus 1 is not, see, we should prove that there is no rational number like that. There is no rational number like that, but we are assuming that it is a rational number. So is not an irrational number. So since it is not an irrational number, then it should be a rational number. Hope you understand. According to the given problem, root over n minus 1 plus root over n plus 1 is a rational number for no value of n. For no value of n means it is always irrational number. That is what is the information given. That is what you will have to prove. So to prove that it is irrational number, according to our indirect method of proof, let us assume that this number is an irrational number. Sorry, this number is not an irrational number. Since it is not an irrational number, it should be a rational number, right? So since it is a rational number, again every rational number can be expressed in the form of p divided by q is equal to p by q. So provided that p, of course q is not equal to 0, p comma q are integers, and of course GCD of p comma q is equal to 1. Okay, so how do I simplify? Should I square it on both the sides? If I square it on both the sides, then what do I get here? Root over n plus 1 will be n plus 1 plus n plus 1. So plus 1 minus 1 gets cancelled. I get 2n plus root over n square minus 1 is equal to p square by q square. So root over n square. So even if it is a square, so then okay, so then also you can say that it is irrational number. Now I'm going to prove by another way. Of course, I will explain both ways. Okay, you please do remember what are both the ways. I'm going to square it on both the sides. So when I square it on both the sides, whole square and whole square, it is in the form of a plus b whole square. What is a plus b whole square? A square, it means root over n minus 1 whole square, plus b square, that is root over n plus 1 whole square, plus 2ab, 2 into root over n minus 1 into root over n plus 1 is equal to p by q whole square is going to be p square divided by q square, right? Root over n minus 1 whole square is n minus 1 and this is n plus 1, and plus 2 into root over n minus 1 into n plus 1 is n square minus 1 is equal to p square by q square. Of course minus 1 and plus 1 cancel, n plus n is equal to 2n. Okay, so I'm going to transpose the 2n that side. So 2 into root over n square minus 1 is equal to p square by q square minus 2n, which is equal to p square minus 2q square n divided by q square. Okay, this is 2 root over n square. Then root over n square minus 1 is going to be p square minus 2q square n divided by 2q square. Once you observe this, here n, show that there is no positive integer n. There is no positive integer n. I am taking n is one number, completely one number, any number. Then if n is any number, then n square, suppose if I take n is equal to a positive integer, Square of positive integer is equal to positive integer. Positive integer minus 1. Positive integer minus 1 is also a positive integer. Square root of any positive integer is an irrational number. And n is equal to negative number, for example. So negative number whole square is equal to positive number. Positive number minus 1 is also positive number. So square root of positive number is an irrational number. So for any value of n, square root n square minus 1 is always an irrational number. So this is an irrational number. Obviously what it is a rational number. It is a rational number for any value of n. So here irrational number is equal to rational number. Again it is a contradiction. So this is the contradiction is only due to our assumption. Therefore our assumption is wrong. Therefore root over n minus 1 plus root over n plus 1 is an irrational number. This is what is the conclusion about this problem. This is one way of solving the problem. And another way of solving the problem is, see here, I am going to solve this problem in another way. So that way is going to be same. I am going to choose indirect method of proof by indirect method of proof. Let us assume that root over n minus 1 plus root over n plus 1 is not an irrational number. Since it is not an irrational number, it is a rational number. It can be expressed in the form of p by q. You know about p comma q are integers, and of course HCF of p comma q is equal to 1. Q is not supposed to be 0. This is what is according to the definition of a rational number. Since there are two numbers, there are two different irrational numbers, I am going to rationalize this. But in order to rationalize, we all are aware of and we all are familiar with rationalizing the denominator, right? But it is only the numerator. To make it denominator, I am going to take the reciprocals of both the fractions. Then the fractions will become q divided by p, because the reciprocal of p by q is equal to q by p, and it is going to be 1 by root over n minus 1 plus root over n plus 1. What should I do? I should rationalize the denominator by its rationalizing factor. So what is the rationalizing factor of denominator? Root over n minus 1 minus root over n plus 1 divided by the same thing, root over n minus 1 minus root over n plus 1. So what do I get finally? Q divided by p is equal to root over n minus 1 minus root over n plus 1 whole divided by, a plus b into a minus b, of course a square minus b square. A square is square root n minus 1 whole square is n minus 1 minus root over n plus 1 whole square is n plus 1, but minus is there before. So minus of n plus 1 is minus n minus 1. So minus n plus n cancel. Here minus 1 is going to be minus 2. So that finally what do I get here? Root over n minus 1 minus root over n plus 1 is equal to minus 2q divided by p. Got it? This is the first one. Okay, root over n minus 1 minus root over n plus 1 is equal to minus 2q by p. See here, this is one equation, and root over n minus 1 plus root over n plus 1 is equal to p by q is there. I am going to take this. Let me take this is first equation and this is second equation. These two are two equations. Is it possible for me to get the value of root over n minus 1 as well as root over n plus 1 by solving these two equations by any of our algebraic methods? Absolutely. See, this is in the form of a plus b is equal to something. It is a minus b is equal to something. So that I can solve both of them in order to get the values of root over n plus 1 as well as root over n minus 1. So the first thing that I am going to take here is getting the value of root over n plus 1 or n minus 1. I am going to solve them. See, when I add both the equations, if I add equation 1 and equation 2, okay, when I add equation 1 and equation 2, root over n minus 1 plus root over n plus 1 plus root over n minus 1 minus root over n plus 1. So minus value plus value gets cancelled. root over n minus 1 plus root over n minus 1 is going to be 2 root over n minus 1 is equal to, here right hand side is p by q plus right hand side is minus 2q by p, right? So when you simplify, you get 2 root over n minus 1 is equal to p into p is equal to p square minus 2q square divided by pq. So transpose is 2 also here. So divided by 2. This is the value of root over n minus 1. And similarly, I would get the value of n root over n plus 1 also by subtracting second one from the equation first one. So first equation minus second equation will become root over n minus 1 minus root over n minus 1 gets cancelled. This is root over n plus 1, root over n plus 1 minus of minus plus root over n plus 1 become 2 root over n plus 1. So 2 root over n plus 1 is equal to p by q minus of minus 2q by p is nothing but plus. So p divided by q plus 2q divided by p. Okay. So here 2 root over n plus 1 is going to be p square plus 2q square divided by pq. Okay. So p square plus 2q square divided by pq, and then I am going to get this. So if you send this to here, then it is going to be root over n plus 1 is equal to p square plus 2q square divided by 2pq. So this is the value of root over n plus 1. See, root over n minus 1 value is this and root over n plus 1 value is this. But according to the given problem, there is no positive integer n for which this number is a rational number. It is purely rational. It is purely rational. But in both the cases, you are getting rational which is equal to irrational number. Is it possible? A rational number never be equal to irrational number. So therefore, it is a contradiction. This contradiction is only due to our assumption. Therefore, our assumption is wrong. So in these two ways, you can prove that this number is, there is no such positive integer n. There is no such positive integer n given that this number is a rational number. Okay. So that number is always irrational number. That is what ultimately you proved. Hope you understand. Yes. Let's move on to the next problem. Here the next problem is, observe this, 144 cartons of Coke cans and 90 cartons of Pepsi cans are to be stacked in a canteen. If each stack is of the same height and if it equal contain cartons of the same drink, so what would be the greatest number of cartons each stack would have? So according to this problem, it is understood that you need to find out the greatest number which divides both the two numbers. Okay. So according to the given problem, we need to find highest common factor of 144 and what is another number, and 90. So how do we find the highest common factor of 144 and 90? Let's go by any one of the methods. I go with short division method. 90, 144, 90 ones are 90, and then 54. Okay, and then 90, 54 ones are 54, and then what do we get? 10 minus 4 is equal to 6. 8 minus 5 is equal to 3, and then 54. So 36 ones are 36. 14 minus 6 equal to 8. 4 minus 3 equal to 1. 18, and then 36. So 18 twos are 36. So finally what do I get? 18 is the HCF of these two numbers. So it means the greatest number of cartons each stack would have. So greatest number of cartons each stack would have each stack would have is how many? Is 18. So if there are 18 cartons, then this 144 as well as 90 can be divided equally. You understand? These kind of problems are pretty much easier in order to find whatever the result is. Next, moving on to the next problem. The next problem is, if p is a prime number, then prove that root p is an irrational number. This is one of the problems that we discussed in the very beginning of this module. How to prove this root p is irrational number, where provided p is a prime number. Prime number means root over 2, root over 3, root over 5, root over 7, these kind of numbers. So now I'll give you one systematic proof. Please do remember and concentrate. Whatever the method I do, I follow, I will write on the board. So the same for every single problem of the same kind. Root over p, in the place of p, if you have 2 or 3 or 5 or 7, whatever it is, you just replace that number. Automatically the result remains same, but the method that I am following. So here the proof is going to be by the indirect method of proof, by the indirect method of proof, by the indirect method of proof, let us assume that root p is not an irrational number. If root p is not irrational number, then it is rational number. Let us assume that root p is equal to a rational number. Is a rational number. So we know that every rational number can be expressed in the form of p by q, but p is already there. Let us use a by b. So root p is equal to a divided by b, provided b is not equal to 0. A comma b both are integers, and HCF of a comma b is going to be 1. I am telling you again that HCF of a comma b is equal to 1 plays a major role in this. Okay, right. So root p is equal to a by b. How do we simplify this? Since we have a square root, it is understood that you will have to square it on both the sides. Okay, so when you square it on both the sides, you get p square is equal to a square by b square. So p square is equal to a square by b square. Then a square is equal to p square into b square. A square is equal to p square into b square. What do you mean by this a square is equal to p square into b square? It means a square is a multiple of p. A square is a multiple of p or p square, whatever it is. See, a square is a multiple of p square means, I will give you one example, so that because everything is an unknown number, that is why you might get confused about this. Suppose you have a number root 3. Root 3 is equal to a divided by b, for example. Okay. Squaring on both the sides, 3 is equal to a square by b square. So it means a square is equal to 3b square. A square is equal to 3b square. Sorry, I wrote here p square. A square is equal to 3b square. So if a square is equal to 3b square, it means a square is a multiple of 3. A square means it's a square number. A square number is a multiple of 3. Tell me one square number which is a multiple of 3. What are square numbers? 1 square, 2 square, 3 square, 4 square, 5 square. All these numbers are square numbers. Okay. I am taking one square number which is a multiple of 3. Can I take 3 square? Because 3 square is equal to 9 is a multiple of 3. So I am taking a square is equal to 9, because you can write that 9 as 3 into 3. 3 into something, whatever it is. So since a square is a multiple of 3, means a square is equal to 9. From this, what is the value of a? A is equal to 3 square. A square is equal to 9. So a is equal to 3 plus or minus 3. Of course, a is equal to 3. Positive number that I am taking. Can I write that a is equal to 3 as 3 into 1? It means when a square is a multiple of 3, then a would also be a multiple of 3. A square is a multiple of 3, then a would also be a multiple of 3. Please do remember, this is not only for 3. If a square is a multiple of 2, then a would also be a multiple of 2. If a square is a multiple of 5, a would also be a multiple of 5. If a square is a multiple of 7, a would also be a multiple of 7. You understand? Like that, a square is a multiple of p, because a square is equal to p into b square. So since a square is a multiple, a square is a multiple of p, then a also a multiple of p. A also a multiple of p. So a also multiple of p means, can I take a is equal to multiple of p means, can I take p into m, where m is any positive integer. Okay, so a is equal to pm I am taking. So let me take this equation as first equation. So I am going to substitute that in the equation given. What is that first equation? So the first equation is going to be a square is equal to pb square. I am going to substitute this in the first equation. So when I substitute this in the first equation, then the first equation will become, see here, a is equal to pm, substituting in the first equation. So first equation will become a square, a is equal to pm, so pm whole square is equal to pb square, so pb square. Pm whole square is going to be p square m square is equal to pb square. Can we cancel one p and one p here? Finally, what we get here, b square is equal to pm square. B square is equal to pm square. What do you mean by this b square is equal to pm square? This is same as like this, a square equal to pb square, where a square is equal to pb square means a square is a multiple of p, then a would also be a multiple of p. Similarly, b square is equal to pm square. It means b square is a multiple of p, then b would also multiple of p. Therefore, I am taking the value of b as b is equal to p into some other number n, where n is any positive integer. Hope you understand how did I take the values of a and b. Since a square is a multiple of p, then a would also be a multiple of p. B square is a multiple of p, then b would also be a multiple of p. So I got the values of a as well as b here. What am I going to consider now? Consider the value of a by b. Consider a by b, where a is equal to pm divided by b is equal to pn. So pm by pn. Now you once observe what is that pm by pn and how do you understand that pm divided by pn. Can we cancel p and p there? Yes, of course we can cancel to get its simplest form. But before you cancel that, you have to understand one more thing, that what is the HCF of pm and pn. The HCF of pm and pn is p, because p is the common multiple or common factor of both the two numbers pm and pn. So it means here the HCF of pm and pn is p. HCF of pm comma pn is p. HCF of pm and pn is nothing but HCF of a comma b only, no? So which is p, but not equal to 1. Here you have taken HCF is equal to 1. Here you got HCF is equal to p, but it is not 1. So what does it mean? It is a contradiction. So this contradiction is only due to our assumption. So you have assumed that root p is equal to a rational number. Just because of this assumption, we arrive at a contradiction. So therefore, our assumption is wrong. Therefore, our assumption is wrong. Since our assumption is wrong, therefore, root p is an irrational number. Root p is an irrational number. You understand? So this is what is the systematic way, systematic proof in order to answer these kind of problems. And these problems are very much easier. See, I have explained the problem with root p. There, p can be any number, but the number of steps remains same, the procedure remains same. Suppose if you are asked to prove root 2 is a rational number, In the place of p, you write 2. That's it. Suppose if you are asked to prove root 3 is irrational number, same thing. Whatever the number, the procedure remains same. And remember one thing, it's a compulsory problem in your board examination. Right? Move on to the next problem. So the next problem is going to be, prove that n square minus n is divisible by 2 for every positive integer n. So you are going to prove that it is n square minus n is divisible by n square minus n is divisible by 2 for every positive integer. It means if I take n square minus n is equal to some p, okay, let p is equal to n square minus n is divisible by 2 for every positive integer n. So n is being a positive integer, okay. You will have to prove that n square minus n is divisible by 2 means what? N square minus n is equal to 2 into something for any value of n. Since n is being a positive integer, then I have two types of positive integers. What are those two types of positive integers? One is odd positive integer and one is even positive integer. So every odd positive integer can be expressed in the form of 2n plus or minus 1. It could be either 2n plus 1 or 2n minus 1. And every even positive integer can be expressed as 2n. Of course, you are using n here. Change to another variable, that is some 2k plus or minus 1, or this is 2k. Now I am going to take the value of n is equal to an odd number and then n is equal to even number. Okay. So case 1 is going to be if n is odd. So if n is odd means I am going to take the value of n is equal to odd number, that is 2k plus 1. If you substitute that, then p is equal to 2k plus 1 whole square minus of 2k plus 1. Okay. 2k plus 1 whole square is in the form of a plus b whole square. A square, 2k whole square is equal to 4k square plus 2ab. 2 into 2k equal to 4k into 1 is equal to 4k plus b square, 1 square is equal to 1 minus 2k plus 1, minus is there, so minus 2k minus 1. So here minus 1 plus 1 gets cancelled and is going to be 4k square minus 4 plus 4k minus 2k is going to be plus 2k. So totally I think you can take one 2k common, right? So 2k times here 2k plus 1. 2k times 2k plus 1 is nothing but 2 into some other number alpha, whatever. Here it is k into some number now. I am taking that k into some number as alpha. So it is 2 into alpha. What is 2 into alpha? It's always an even number. So for n is odd number, n square minus n is divisible by 2 means it's an even number. Okay. Now if you take p is equal to, sorry, n is equal to 2k plus 1, even 2k minus 1, if you take 2k minus 1, then it is going to be 2k minus 1 whole square minus of 2k minus 1. Then what will be here? 2k minus 1 whole square is again in the form of a plus a minus b whole square. So a square 2k whole square is equal to 4k square minus 2 2s are 4k minus 1 whole, sorry, plus 1 minus 2k minus of minus equal to plus 1. So here this is 4k square minus 4k minus 2k equal to minus 6k and then plus 2. So every single number there is 1 2 common. So if you take 2 common, then it is going to be 2 into 2k square minus 3k plus 1. It is going to be some 2 beta, because 2 into this is some other number. Then also it is divisible by 2. Next, when this is the case 1, when it is an odd number. When it is an even number, in case 2, if it is an even number means what? If n is even, then I am taking n is equal to, even number means can I take 2k? Then when I substitute in p is going to be n square minus n, it means 2k whole square minus 2k. 2k whole square equal to 4k square minus 2k. So totally I can take one 2k common, remaining 2k minus 1. See here 2 into some other number, let it be, so 2 into some gamma is divisible by 2 because it is 2 into something. Therefore n square minus n n square minus n is always divisible by 2. Either p is an even number, sorry, n is even number or odd number, it is always divisible by 2. See how to simplify this problem and how to prove this problem. It's pretty much easier. So moving on to the next problem. If a and b are positive integers, then show that root 2 lies between a and b and a by b and a plus 2b by a plus b. First of all, you will have to get one idea in order to answer this problem. Our answer is going to be root 2 lie between these two numbers. A by b is smaller than a plus 2b by a plus b, then a by b less than root 2 less than a plus 2b divided by a plus b. Otherwise, suppose if a by b is more than a plus 2b by a plus b, we do not know that. Then we need to prove that a plus 2b divided by a plus b less than root 2 less than a divided by b. So you will have to prove this. In order to prove this, you will have to understand one thing, that a by b, suppose if a by b is smaller than a plus 2b by a plus b, then the difference between a by b and a plus 2b by a plus b should be the value root 2 it contains. So I am going to take the first case. So the case 1 is, suppose a by b is less than a plus 2b divided by a plus b. Okay, suppose, then transpose this towards left hand side, then a by b minus a plus 2b divided by a plus b must be less than 0. Then when you simplify, a into a is equal to a square plus a into b equal to ab minus a into b is equal to ab minus b into 2b equal to 2b square whole divided by b into a plus b less than 0. Right? So here when it is less than 0, then provided the numerator is less than 0, then the total number is less than 0. So if the numerator is less than 0, here minus plus cancel, then a square minus 2b square less than 0. A square minus 2b square less than 0 means a square less than 2b square. So divided by 2 on both the sides. Then okay, fine. So a square minus 2b square, we want that b square, right? So since you want b square, I do one thing. You want a by b. So since you want a by b, first of all you transpose this minus 2b square that side, then a square less than 2b square divided by b square on both the sides. Then a square by b square less than 2. So a square by b square less than 2, then we can easily write the value of a by b less than square root 2 if you take square roots on both the sides. Because a square and b square both are positive numbers, taking square root does not matter. So a by b is less than 2. A by b less than root 2 means what? A by b value smaller than root 2. A by b value smaller than root 2 means what? Root 2 must be more than a by b only, no? So then we can say that the number root 2 is more than a by b means it should be more than that. It should be more than that means it should be less than a plus 2b by a plus 2b by a plus b. That is the first case we proved. And coming to the case 2. So what is this case 2? In the second case, for example, a plus 2b divided by a plus b less than a by b. Suppose if this is less than, then we do one thing. A plus 2b divided by a plus b minus a divided by b less than 0. Okay? Again, a into b equal to ab plus 2b square minus a square minus ab less than 0. I am writing directly. So ab gets cancelled. Here 2b square transpose minus a square that side less than a square. Now transpose b square also that side, otherwise divided by b square. So divided by b square. 2 less than b square by a square. 2 less than b square by a square means what? B square by a square greater than 2. B square by a square greater than 2 means b by a greater than root 2. See here, b by a value greater than root 2. b by a value greater than root 2 means root 2 is less than b by a. Why root 2 less than b by a? because a plus 2b by a plus b is smaller. So in both the cases we proved that root 2 lie between a by b and a plus 2b by a plus b, right? So hope you understand how to answer these kind of problems, and these are some hot kind of problems. Of course we can expect these kind of problems in this situation because you are getting a lot of gap between the examinations, and of course the exams are being postponed, so that you will have to go through everything. That's why I just gave you some extra information in order to score more than 80% easily. Hope you understand, enjoy the class. Thank you.